Okay, hopefully you can hear me alright. Tonight I thought I'd do a bit of a video on the different power supplies that I've got here. I've got there's two old telephone ringing generators. These are AC dynamos. This one here has one single magnet in it. I don't know whether we can get good lighting on that. That's the magnet there, and inside there is an armature with a coil on it that rotates. You can't really get a real good view of that, but it's just at the back there. It also goes through this capacitor or this condenser. The output goes through that condenser there, and I'm not sure the value of the condenser, but the coil has got the ohmage stamped on it. It's a 400 ohm coil. So that's one output. Well, that's one dynamo that we'll have a look at. This is the other one here. This is a 4-pole magnet telephone dynamo. It's also got a single coil in the center. The difference between the two is that this one has a laminated core, and obviously four different magnets on the outside. They both put out about the same voltage, as we'll see in a minute. I've got the multimeter there that I'll hook up as it's spinning. But I've also got this little bicycle dynamo here, which we'll have a look at as well, and see the signature on the scope, and we'll see what effect it has on this little setup here. What I've done here is I've soldered, whether we can get that in focus, there we go. I've soldered 4 diodes together. I've got a positive out there, and a negative out here on this end, and in between I've got 2 LEDs with their negative legs tied together. So the smaller post inside the LED is soldered together. So we've got negative to the center, positive out here, and then this end's positive and this end's negative. So we'll see what effect the dynamo has, or the different dynamos have, on this little array. And to see that, I'll turn the lights down later on, and we'll check that out. So if you can bear with me for a little while, we're going to have a bit of a play. First up, we'll check this. Hopefully you can see the oscilloscope screen, and if I zoom in, you can see that it's already picking up the 50 Hertz that's here on the table. It's probably this transformer here, which is actually powered on. Something of it was. The rest of it's probably just this line and all that sort of thing. But if we go down to 2 volts per graticule and give this a spin, you can see it's quite jumpy. So we'll go to 5 volts. The probe is set to ×1, and the meter, hopefully you can read the meter. I'll try and keep the speed steady. .3 volts, and you can see that the scope's not really showing it, so I'll go to ×10, and I think it's 2 volts per graticule, ×10, back up to 5. There we go, that's a good signal there on the scope. So that's about 25-30 volts. And you can see that the signal on the scope is pretty true to form for an AC sine wave. There's a bit of room between the 2 peaks, and I'm sure if I spun it faster, that then closes up as the voltage increases, frequency increases. Sorry. So that's that one. Now we'll go to the other one. Okay. So that's 49, 46 volts there. This one actually puts out a bit more voltage than the other. If I crank it up the same sort of speed, it's actually about 80 volts, 80 or 90 volts. But basically the same sort of signature on the scope, or the same readout on the scope. And now we'll go to the bicycle dynamo. There's our leads here. And I'm not going to be able to spin this constantly, I'm just going to be able to flick it with my finger. And that'll have to do, but you'll get the general idea. And very shortly you'll see the difference in the signatures that I talk about a lot, the AC signatures being different outputs. So this is the dynamo. Yep. I might just have to go back to 5 and I'll go to 1 on this, times 1 on the code. There we go. So you can see that there's a lot less room between the peaks and troughs. That's a true sine wave. There's no delay. No plateau between the peaks. Right, now what we'll do is check this out with the diode bank. So the first thing we'll do is we'll use this first one that we used. Oh no, sorry, the first thing we'll do is we'll have a look at this diode here and be able to then make sure that we can see it with the light. So I'll turn off the overhead lights, I'll turn them down to the point where we can see the table. And now, hopefully, you can see that that's lit. So now that's the permanent, that's the 12 volt out of the transformer. I'll now go to a dynamo, this one here, the first dynamo that we tested on the scope, just to make sure that this is actually going to output the a sine wave or a pulse and light the dynamo, light the LED. So we'll just go straight through that one. There we go. You can see it blinking. Hopefully that's coming through a lot. I can't actually see that on the screen, but oh yeah, there it is. Alright, so that's blinking, no worries. Driving that single LED, not a problem. Now, what if we go to either side of this bank of LEDs here? So we're going from the positive leg across to the negative, and then from that negative leg across to the positive leg. So I'm hooking into both positives. Let's see if that lights up. And of course, as you can see, they both light up, and independent, like one and then the other. It's a flashy thing. and we can have a look on the scope of that too in a minute, but first I'm going to go now to the positive leg out there, instead of then being positive, negative, positive. We're going positive, negative, positive, and then another positive. One tiny weeny little flash there, and that's all, finished, finito. So I'll go back to this positive here and come out to this negative. Give it another crank. Nothing at all. So there to there we've seen, that to that we've seen, that to that we've seen. Okay, so what we'll do is come across to there and have a look at that on the scope. Oh, wrong one. Let's put that out there. So let's watch the scope. So we can see that there's actually energy there. I'll go times 10. See that the waveform looks pretty much the same as it did before between the two posts, but there's no light. So we'll go out here to the negative side. So we're now going through the whole thing. And again it looks the same, but there's no light, no current flow, just voltage. Alright, so that's that one. Doesn't work on the positive to positive leg. Sorry, does it work? Go back to the original setting, positive to positive leg. Oh yeah, it is working, look at that. And we can have a look at that on the scope. So the scope's now showing rectified pulses, all in one direction, by the way. Okay, that's that one. So that's our first little power supply. Taking that out of the way. Now we've got this one, this bigger, crankier one. And like I said, the only difference between these two is that this one puts out a little more voltage, and this one has a laminated core. Oops. So, once more, flashy, and you can really see the alternating potential there with this one. It's actually, even though it's not going through a condenser, it's quite a lot brighter. So we'll have a look at that on the scope. You can see that there's barely any movement there on the scope at all. I'll zoom in, go to 2 volts per graticule, and that's delivering a slight amount of energy on the lower end of the trace, but not very much. I hope that's coming through okay, I'm not really sure. So, that's to the outer legs. Let's go one out there. So one post now to positive. Oh, look at that. One light is flashing. Gee, eh? one light but not the other. Well, let's see if it happens the same way on the other side. So let's put that one back there and this one out there. Hang on, that's the same light that's flashing. What's going on? Go back here. Back there, so we've got 1 to positive, and through to positive, then negative, through to negative, then to positive. So we've got positive connection out here, and a positive connection out here. And that one's blinking. Oh, okay, what if we go then to that positive there and this one out here and negative? What happens now? Same one's blinking. What happened to the other one? Why isn't that going? Why is it not both? Now it's both. What's different? Why is it that that one doesn't come on? What if I go to the middle and out to here? Was that what we did before? No, that's not what we did before. That's not lighting. That LED is not coming on. Interesting. Should we look at it on the scope? So this is when it's not coming on. Nope, I'm going to have to zoom out. So we've got just one pulse there. The other half of the sine wave is gone. When we come across to where it does work, to there, looks the same. It looks exactly the same on the scope. My goodness me. Now, if I go to the middle, oh sorry, to the positive, positive, no, that's not positive, positive, is it? To the negative, negative, no, positive, positive, that's right, yeah, positive, positive, okay, positive, positive, and we get on the scope that rectified trace. So when I go negative this side and positive this side, I get nothing, but it shows me on the trace annoying. That looks exactly the same, apart from it being below the line. That looks exactly the same as the other side. No, not even from below the line, because that I've just zoomed out, and that looks exactly the same. No, not exactly the same. This line here, the null point, is sitting on 0, whereas before it was dropping down a little. Now, it might be a little, might be the same. Zoom back out. No, it's the same. Cool. Alright, so that's that one. That's that power supply of higher voltage and uncondensed, not going through a condenser at all. Now let's go to the bicycle dynamo. This AC dynamo that is not brushed, no, it's just pure induction, not rectified in any way. But I've got to spin it by hand. So we'll put the scope across it straight away so that we're not wasting people's time by doing two different tests to give the same results. So this is the one that's lighting up that wouldn't light up before. Nope, that's that turning off. Times 10, I've got to go to times 1. So that trace looks exactly the same. Traces across between the 2 points, between the outer legs, between the 2 positives. If I go between the centre and a positive, looks about the same. So what if I go from the generator, from the dynamo to an outer leg, and the middle, so we're just trying to light this one, just trying to light the one that wasn't lighting when we had both connected. What happens now? It's lighting. What's going on? Let's have a look at the scope trace now between those 2 points. It looks exactly the same. But that's lighting now. Why is that lighting? I'm going from negative through to a negative through to the positive, and that's lighting. So that's okay, that's fair enough. But when I go across to the positive, so I'm going now negative through to a negative, through to a positive, through to a negative, through to a positive, nothing lights. And when I go between the 2 here, only one lights. When I go to the other end, neither of them light. So to the middle, so I'm going now from a positive to through the negative to a positive, through to a negative, so positive to negative. It's not lighting. The scope trace looks exactly the same everywhere. Everywhere I go, it's all the same on the scope. But that light there is not lighting, and yet when I go through the diode, through the LED, it lights without a problem. If I go through the other LED, it lights without a problem. Why can't it light both? So, 3 different dynamos, 2 the same, 2 similar looking AC signatures on the scope, one looking like a pure sine wave, but not behaving like a pure sine wave. The other 2 act like a pure sine wave, or look like a sine wave through the diodes. They alternate through the LEDs, changing polarity. But this dynamo, this little bike dynamo, is completely different.